Hey guys, we explored vectors, vector subtraction, and now it's the right time to have an application to some GCSE problem and questions that you might need on your exams. Alright, so that's how subtraction works. I remind you, basically subtraction is simply addition with the opposite components, with the opposite vectors. So I hope you understand how it works. If not, just watch the previous video dedicated to vector subtraction. And now we go to application. So that's the first problem that we are going to consider. Alright, so what we have a boy that's trying to fire a bullet at the target. Okay, so in calm condition, when there is no wind, the bullet would travel at 250 meters per second. Wow. Okay, it's pretty fast, but not at the speed of sound, right? Which is 330 meters per second. So, okay, however, in case of the wind blowing with a speed of 50 meters, that's pretty strong, from a boy's left hand. So the wind is blowing from the boy's left hand, so it means from there, okay? From there to, and actually blows directly across the bullet pass. So the bullet pass, let's say to the north, it goes, the wind blows from the west across, so basically perpendicular to the north direction. So the boy needs to adjust trajectory in order to shoot directly at the target. So yeah, definitely, right? If the wind, so definitely the strong wind will influence the bullet that goes so that the trajectory is going to be bent. So that's why we approximate with straight lines, because the target is not supposed to be very distant from the boy. So we assume that all tracks, all the trajectory, all the paths are straight lines. Okay. So, and in what direction should the boy fire the bullet so that to get to the target? Okay, that's the first question. And let's set up some, let's set up the boy, which is here. So probably let's set up here, that's the boy. So let's say the target is here, straight to the north, that's the target. And the boy is going to fire in calm weather, obviously, in calm conditions, when there is no wind, the boy will strike that way, right, to the north. And with a speed of 250 meters, it will get the target. However, in case of wind that goes from the west, so we can say that actually we can set up the wind velocity this way. This is the wind velocity, which is 15 meters per second. That's the vector. So obviously in this case, if the boy would strike still to the north, right, according to addition, you'll get, so let's have a little experiment. So if this is the vector that the boy actually fires with velocity 250 meters per second, what actually we need to do? We need to find resultant velocity, which is simple addition v plus w. Okay, and in this case, it definitely want to get the target, because according to addition rule, we need to translate w vector so that they will arrange triangle. And according to the triangle rule, for example, I'll use the blue color, the bullet actually pass will be hypotenuse, or basically this vector according to the addition rule. So that's going to be v resultant. But in this case, if the boy will strike to the north direction, the bullet will miss the target actually. So obviously it's not correct. So the boy needs to change direction of the strike, right? And according to rules, what actually will happen, so I just erase that because it's incorrect for this problem. It was just our speculation, so I erased that. And according to conditions, the boy needs to strike exactly this way. Look, that's the path, or that's, sorry, not the path, but this is initial direction of the velocity for the bullet. Okay, so that is going to be v bullet, but not resultant. So that's why this v is simply here, which is 250. But that's the question. You know why? Because that's actually, we are asked in what direction should the boy fire, but we are not asked about it's going to be which velocity we need to set up for this direction. Okay, we can, yes, we can find this angle theta, let's say. We can define direction using the ratio, but we are not clearly state at which speed the bullet needs to get to the target. So probably if we set up 250 as still the same gunshot power for the bullet, definitely this vector that is going to be a resultant, and that's simply, as you can see here, that's simply addition rule for vectors, right? So v resultant in this case is still v plus w. However, hold on, we know that this is a right angle triangle, so v resultant is going to be less than v absolutely. Okay, it's going to be less than 250 meters. What if it's not enough for the bullet to reach the target? Yeah, that might be the case, because it will lower the speed. It will lower the speed, so maybe it won't reach the target, especially in the case of air resistance. Okay, but this is sort of speculation. So it means that what's the problem actually? No one asked the textbooks when he or she sees such problem, and probably never asked the teacher. But look, we understand the gun power. The answer is pretty clear, that the gun power is not changing. It means it still shoots with the same velocity, but initial velocity, but he needs to change just direction. So that's why this is the right speculation. Yeah, we understand that resultant velocity is going to be less, absolutely, than 250. It means that, okay, due to the wind, it probably can't reach the target. But this is the other question. So we assume the gun power is still the same, so velocity, initial velocity is not changing. That's our assumption. So assumption here, assumption that gun power is not changing, so is constant. That's mostly about physics, guys. I understand that in math, you less likely ask sort of questions, but from the physics point of view, it's a reasonable question, and better if you, somewhere at class, try to drop this question into the auditory. It's very interesting what the answer will be from your teacher's side. So how he or she will speculate at this topic, okay, about this topic. And if she or he answered it in different ways, so please drop the comments. It will be very interesting. Okay, I hope to see some comments if you ask this question to your teachers. So right now we assume that gun power is constant, so it means initial velocity, initial, is still be 250 meters per second. So that's why our direction is changed. So by the angle of theta, the initial velocity speed is still 250 meters. Okay, that's absolute, of course. Okay, so let's have this task as the initial one. So what we're gonna do, we're gonna say that in terms of resultant velocity, we see that v resultant is simply v plus w. Okay, so however, if you rearrange, we understand that, look, we understand that if you express, for example, v from there, you'll get v resultant minus w. And that means you actually have a subtraction. Here is where subtraction is clearly seen, okay? However, we don't need to express that, because my goal and the goal of this problem is to find exactly this leg, which is unknown. So we need to find the actual direction, so we will use definitely angle theta as determinant of how we can calculate the angle and direction. Okay, so let's do that. We are given basically hypotenuse, we are given the opposite side, so we use sine rule or sine ratio for the right angle triangle, so for the triangle. So we know that opposite side, according to the formula, is hyp times sine theta in this case. So if we put the values, so we'll get the opposite side is 15. So we've got 15 equals to hypotenuse is 250 times sine of theta. So from where we can express sine theta, and we get sine theta is basically the ratio 15 to 250. Okay guys, actually you can use initially, if you remember SOHCAHTOA rule, so you can use that. For me it's easier to start from that as the starting point, because later on I can simply rearrange and I clearly remember this stuff. I don't need to use SOHCAHTOA rule, okay? So we figure out sine theta, from where theta is simply sine minus 1 of that fraction. As you expect to have, it's very small fraction, and so as the angle itself, because the smaller the fraction, sine also becomes smaller. So we use second set and calculate arc sine of sine minus 1, 15 over 250. So we've got approximately 3.44 degrees. Okay, that's the angle, and we actually found this direction. So we answered the first part. Okay, the next question, what is the actual speed of the bullet? So the actual speed is the resultant vector. How to determine it? Okay, knowing the angle we can figure out. Knowing the right angle triangle we can use Pythagoras. So actually you can calculate in two ways. That was A and now B. So for example, I would set up Pythagoras. So V squared is simply V resultant squared and plus W squared, from where we can express V resultant, which is square root of V squared minus W squared. So V resultant is going to be equal to, so V squared in our case is 250 squared and minus W, which is 15 and squared. So guys, if you by chance in some problem you've got the negative value as a result under the square root, so looks like you actually maybe incorrectly complete the vector equation or probably set up the triangle. So in this case you need to think and go back and one more time to rebuild triangle so that this difference is going to be positive, because you are not able to have negative value unless you're looking for complex solutions. So complex is not for GCSE definitely. So complex numbers are not for this program. So that's why you need to have the actual real result. Okay, in our case we can simply calculate that. Let's do square root of 250 squared minus 15 also squared, and we've got 249 and 0.55, 2 decimal places. So that's the actual resultant speed, and as we expected and set up, it's going to be less than 250. So that's the reasonable question. Is it enough to get to the target? Because if you consider the actual trajectory, for example, I just draw up the picture. So if the boy is standing here and that's, let's say, north direction, and this is the target actually, so you understand that if initial speed, so that's, let's say, the level of where the boy is handing and holding the gun, okay, so the same level, you understand that if distance is not so great, like it can reach without less than a second. So obviously the trajectory is going to be very, very close to straight line. However, if the speed is slightly less, so it can influence on the trajectory, and probably the trajectory bend early so that the bullet can reach the target. So that's why I'm saying if it's not enough, so like its speed not enough, 249, that might influence the real track. And this is the question about physics. So you see the deepness of that problem. However, for abstract math, that's okay. And this is not a problem at all. Okay, so how to calculate V resultant another way around? Of course, you can use different ratios. So V resultant, for example, it's adjacent side, right? Or we can use, let's say we can use tangent rule. So we've got opposite side, we've got resultant side, and we use theta that we recently found. So no matter, I'll just show you quick how to calculate. So opposite to adjacent is given by the tangent of theta, for example. So you can use any trigonometric ratio, sine, cosine, no matter. You are given all the size necessary for that. So in this case, it turns out to be W, which is 15, over unknown V resultant is going to be a tangent of 344 degrees. Okay, so this is a good way to check our previous answer in an alternative way. Okay, so how to find V resultant? So V resultant is going to be 15 over tangent of 3.44. Okay, let's calculate in this way and see what result we'll get. So tangent of 3.44. So I've got, using calculator, I've got the value 249 and 54 again to 254, yeah, 2 decimal place. And you see the correctness actually in 1 decimal place, they correspond. So up to 1. So actually 4 significant figures, if you set up from the very beginning, so 4 significant figures, they are okay, it's okay, but the slight difference if you round to 5 significant figures, in this case, the result will be a little bit different, but that will, so the question actually need to set up on the exam so that rounding and different ways won't have any influence on the final result, correct to a certain degree of accuracy. Hope you understand that was pretty interesting problem that we speculate using physics application. So hope it will be interesting for those who take in physics as well, so mechanics, kinematics, so you can play with parameters and trying to figure out. It's really helpful, and those knowledge you'll definitely apply in your physics. Hope you like that. Put the likes, drop the comments about teachers' answers. It's very interesting, guys. Share with us. Probably you'll have different answers from teachers. Hope you like that. Hope you subscribe already, and peace.